Our last speaker of the day is Karrie Karahalios. Karrie is a professor of computer science here at the University of Illinois, and her research investigates sociable systems for mediated communication using AI and interactive computing. Today, she'll be talking about large language models and education. Thank you, Karrie.
I research socio-technical systems that have computing or mediation associated with them, especially with respect to relationships. I look at bias, I look at outcomes, and I audit these outcomes around efficacy, discrimination, and much, much more, and then build new systems to help people make sense of the algorithmic systems that they use in their daily lives. I think of our work, I've come from the field of human-computer interaction, but I like to think that my work is really more about community-centered interaction and community-centered computing. From this framing, this talk is going to address how people have operationalized such algorithmic systems, consider what we should do before we publicly release such systems, and what mechanisms should we put in place to monitor and consider what mechanisms to put in place to monitor such systems. And I'm going to start with some broader education systems before I get to the crust of what we're working on at the moment, and then move towards grading explanation systems. So how many of you heard about the A-levels debacle in Britain recently? Okay. During COVID, many students in Britain could not sit for their exams, and these exams are critical for getting your seat at university. So the powers that be decided that they were going to use an algorithm to determine what grade a student would have gotten had they taken the test, based on some previous tests and based on the reputation of their current institution. And so lawmakers basically said that this algorithmic system would be fairer in comparison to teachers reporting performance of students, because teachers would likely overestimate or inflate their students' performance. But as you might see where the story is going, the model advantaged students from private schools and more affluent neighborhoods, leaving high performers from public state schools at a disadvantage. The automated algorithm lowered the A-level results of nearly 40% of the students who could not sit their exams, result being that some of them had some of the seats revoked where they wanted to go to school. Another example in education, a system called Proctorio, something we used to use on our very own campus. They claimed their goal was to expand quality education by providing high integrity learning environments to learners across the globe, and it would be a fair way to assess cheating at home as students took exams from home. As you can imagine, it didn't take very long for people to realize that the test proctoring software discriminated against disabled students on many levels. Not only did it mark them as cheating, but it also exacerbated disability-related traumas. And unsurprisingly, students of color were getting flagged as cheating when they were not. And in this case, actually on our campus and many other campuses, students actually came together and protested the use of these tools for many reasons, and also because much of their behavior was tracked. And it was actually interesting to see the protesting happening on Reddit. It kept growing and growing. TAs hated it as well. And eventually, the student-led movement led to Proctorio being phased out of our campus. Now, why do we use such systems? Well, there are many reasons. Some common reasons include that we want to do things at scale, and they help us do things at scale, and they help us do them faster. We cite cost cutting as a reason to use such tool. We cite fairness, although we've seen that in some cases they aren't always fair. And also there's fear, like fear of falling behind. Like if other institutions are using them, other researchers are using them, we're like, we got to use them too, or we're not cutting edge. It's important to note, though, that as we use these systems are not new. In education, automated algorithmic systems have consistently been evaluating our performance. And one of these takes the form of an autograder, which we'll touch on in a bit. But many of you probably remember taking exams in elementary school, your SATs, your GREs, with this bubble format. There's been essay grading happening automatically with GREs for ages. Our CVs have been evaluated by algorithms. And now we're seeing explanations and evaluations in the form of fluent responses. And one example is using Conmigo on the Khan system. Basically, it's a tutor-based system, but also offers explanations and evaluates you. The audience for the tool, by the way, is mostly students, but also teachers use this tool. And it has this chat-like interface that looks something like this. And systems like this are popping up almost every week, whether it be around generating images, whether it be around generating text. They are here, they are easily accessible, and they're not going away anytime soon. So from a bias perspective, we've seen such systems exhibit bias in stereotypical behavior against women, people with disabilities, and much, much more. And while there are benefits as well, I don't want to discount the benefits from sites like these. They are helping people. There have been harms as well. And I'm going to give you an example of a harm as evidenced with a tool to help people with eating disorders. There's a lot of similarities around teaching, tutoring, and mental health. And there's actually going to be a great talk tomorrow around mental health, so please come back and watch that talk. So in this case, the National Eating Disorders Association, or NADA, replaced the people manning a help and education hotline with a chatbot. And this chatbot for eating disorders, named Tessa, was giving people advice on losing weight, which is exactly what you do not want to do to somebody who has an eating disorder. And according to experts, this fuels the eating disorder rather than helps it. So the company initially, or the organization rather, initially dismissed this claim made by an advocate, but later walked back their stance after evidence supported the allegations. And the site was taken down without further notice, and it's still not back up. Now, again, scale, speed, and cost cutting are some of the reasons offered for why we need such algorithmic tools and why we need these AI type interactions, especially the promise of reaching people more quickly. However, one of the things I want to stress is that while these have potential, the hype, promise, advertising is way ahead of the research that shows the effectiveness of such tools. Our university is addressing this. We have tons of pages about this now in a short amount of time, and it's acknowledging the risks in general while cautiously educating us on how to move forward. And while people are generally comfortable with using tools like these, like large language models around transcription and grammar correction, there is controversy around using them for tutors or for grading the way we're using them on this campus. If you want to delve a little bit more deeply into that, there's this wonderful talk by Professor Emily Bender at University of Washington called ChatGPY that I encourage you to watch. At the moment, we know that these systems are on the market. We know that we have no regulatory body to vet such tools before they go on the market. As a research group, we've been conducting algorithm audits now for 13 years. And as people tout the potential, we need to understand the guardrails that we need. So I was thrilled when the White House actually released, or rather the Office of Science, Technology, and Policy at the White House released the blueprint for an AI Bill of Rights. It made it clear what we need to strive for and what we should expect as citizens. And it basically included these, I'm wearing a microphone, okay. It basically included these 5 elements we should look at. And I want to just put them large on the screen so that we all see that this actually brought the discussion to the national level, and it's something we all should be aware of. Now, education. Learning is so complicated, and we have a long history of pedagogy, from personal tutors to assembly line models adopted from the Industrial Revolution around education, to the promise of individualized tutoring with personalized computing and effective computing, different learning philosophies inspired by Piaget and others. With educational opportunity, I must stress, varying based on race, gender, socioeconomic status, and more. Folks in STEM in our department have claimed that science is more objective, so we can use these tools without fearing much harm in our space. But I'm going to argue that that stance needs to allow for some nuance, because we are finding challenges there as well, even with multiple choice questions and the language used in multiple choice questions. Now, I said that I was going to primarily talk about AI auto-grading, and if there's time, sneak in some work around disability. And as I stated earlier, auto-grading is not new. We have many examples of it. There will be many, many more. And many of the reasons that we use it are because the grading generally approximately matches human accuracy. and it saves us work. It's faster. You can grade an entire class of 600 students in seconds versus having and hiring a large group of TAs, coordinating a grading rubric, and so on. But just because something works well on paper doesn't mean people will accept it. So both humans and AIs make mistakes, and trust in algorithmic system drops especially fast when mistakes are made in critical situations. I do want to note, you see I have a fate line going up. There are some people who actually believe in algorithmic power, even when it should not be attributed to the algorithm. But in the testing situation, people typically tend to not trust as much, especially when it does not serve them. I've already mentioned bias. There are fairness concerns, there are justice concerns, and there's no shortage of stories around AI discrimination. And then there are folk theories that people evoke from using these tools. And they use these folk theories around algorithms to adjust their behavior to match. In auto grading systems, folk theories impact how students answer questions to suggest approaches to game, or even to game a system. So I want to fix it a little bit longer on this idea of the folk theories. How many of you have heard of folk theories around algorithmic systems? Okay. Oh, I see a hand. Great. Oh, 2 hands. So we are not the first. I hope you can hear me if I walk away. We are not the first to conceive of the notion of using folk theories. This idea was conceived of by Kempton as he was studying thermostats. And so what he did is, and this was work done in the 60s, he looked at groups of people that used thermostats in their homes. This was an automated system, not AI, but automated. And he basically asked them how they worked and how they used them in their practice. And what he did is, by interviewing them, he found that he could categorize people into 2 basic categories. Groups of people who thought the thermostat behaved as a switch, meaning if the temperature got too cold, past a certain threshold, it would just click on. And another group of people that thought it worked as a valve, similar to our faucets, that if we just kept turning and turning and turning it, we would get more heat. The experts generally believe that it's a switch mechanism. However, what he found was it didn't matter if you were right or if you were wrong. Having a folk theory and being able to compare and contrast your ideas based on it helped you use the system to maximize the benefit and to make you more comfortable. And so I want to stress that this is a big difference between folk theories and mental models. And mental models, well, let me focus on folk theories. Folk theories are extremely helpful, especially when we have non-deterministic systems the way we have today. And they're helping people make sense of sites like Facebook. They're helping people make sense of machine learning, neural network type systems. And they're helping them figure out how to use them in ways by using comparison to actually steer the outcomes that they want. So, this talk really isn't about, is AI grading possible? It's about how should systems be deployed, and should they be deployed at all? And I mentioned explored an autograder. It's been used in an introductory computer science class. It's a large class with hundreds of students every year. The semester we used it, we had 613 students in the course. And the course has been running for several years. The teaching team had assessed the accuracy of the tool already. But I want to stress that these systems don't exist in isolation. Oftentimes when we introduce such systems, we use like this Lego model, we replace a brick. So in the past, maybe we had a human grade exams. We take out that block and put in a new block that has a system grading the exams. And I want to stress that it isn't that simple. If anybody is familiar with Virginia Eubank's work around child protective services, humans, and they use algorithmic AI systems to figure out who needs help at home and who's in danger. What they found is that humans actually know when to override an algorithmic decision, and they know the infrastructure and how to bypass it to get an outcome to help somebody in a way that an algorithm could not. And so there are nuances. These don't exist in isolation, and we need to consider the entire system, the entire socio-technical system, not just that little piece that we're evaluating. So we approached the teaching team of the class and worked with them to create an auditing infrastructure to assess various outcomes of these algorithms. And so let me give you an example of some of the problems in this class. So it's an introductory computer science class. A student is presented with some code, and then they have to explain the code in plain English. And these are called EIPE problems. Once they do that, they type in their answer and they instantly get the feedback. In this case, they get that it's incorrect. Once they get the feedback, they get some exemplar answers. So they get 3 different ones here. And actually, sometimes it's 2, sometimes it's 3, it can change. And then they have the option to report if there's a problem. I want to stress that this was used differently in homework than it was in exams. In homework, people had multiple attempts. In exams, they had 1 attempt. And again, this was imperfect. The false negatives were at 10%. The false positives were at 15%. But this needs a bit more unpacking. By false negatives, we mean that student's answer was correct, but it was marked wrong. By false positive, we mean that the student's answer was incorrect, but it was marked right. And I want to note that the instructors of the course had decided to move the dial up. There's trade-offs between false negatives and false positives. They increased the false negative rate because it made students happier. It increased their satisfaction level with the system. And I was just going to give a teaser. This has impact later on some other outcomes of the system. And so we proceeded to audit this system with them. Another term for this audit is an impact assessment. So we surveyed and interviewed students that had experienced an imperfect short answer grader about how they thought the autograder system worked and their answer construction strategies. We examined various attitudes that explained those attitudes and provided some guidelines afterwards based on our findings. So we used a mixed methods approach. I mentioned there were over 600 students in that course that semester. We think of this as an impact assessment, and I'll touch on that a bit later again. We gathered the experiences of about 71 students through surveys and interviews, and then we used linear regression to find associations between students' attitudes in the study, and used a grounded theory approach to uncover themes in the qualitative data. And so what did we find? Some of the highlights in terms of the folk theories. In this system, and I want to mention that the first system that we used was a bag of words approach, meaning that there was a bank of correct answers, and then people would type in their answers, and it would use similar words based on the correct ones to the ones that the students submitted. And so students kind of got the gist that at the very beginning, there was just some general matching happening. Most of the students realized that there was a bit more detail in the matching, not just getting, people weren't putting just random keywords one after the other. And then some people got even a little bit closer to what was happening, talking about keyword matching with more details. And so some of the folk theories that people had, for example, people felt that more longer answers were better, and so they kept writing and writing and writing and writing. Some people had very specific theories about how it worked and how you needed to have just one word in there that was correct. Some people believed that you needed to have much more specificity. Now, how did the folk theories relate to their strategies? Again, comparison helped them go back and forth. In the case of somebody who thought that more words helped, and again, we paraphrase their answer, the correct answer was something along this line. People kept adding words until they realized that that wasn't getting them anywhere. And then they were going back and subtracting words. It turned out the algorithm, similar to SAT scores, would subtract points for everything you said that wasn't related. So their perceptions. It turns out that students overestimated by far the false negatives, meaning they thought that there were more false negatives than were actually reported, meaning they answered something correct and they were marked wrong. We were surprised that students didn't even imagine that they could be incorrect and marked right. They're like, this never happened in the system. This just wasn't on their radar. The thing I want to stress is also at the same time, the higher perceived rates, the perceived rate of false negatives led them to have lower perceptions of fairness of the tool and lower satisfaction on their exams. And they felt that this could be harmful to learning. So what did we find out from this? We found that this was, okay in low stakes practice. We found that the appeal system was very, very helpful. But this wasn't ideal for an exam-based situation. The other thing we found was having the seamful interfaces, like providing multiple answers as to what was correct was actually really helpful for students to try to see that there wasn't one right way to approach a problem. It provided them cues to see what was valued in the answer, and helped them come up with other related responses. And then this tuning, I mentioned this was tuned to increase the number of false negatives, but we shouldn't focus only on minimizing false negatives to make students happier if it increases false positives, which could be harmful to learning. We need to consider both the impact on learning and students' attitudes when we make these trade-offs. And unsurprisingly, LLMs became a tool as we were working on this, a tool in the toolbox, and they were incorporated into the system. And so remember our question. This was the first question that I touched on earlier in the talk. Putting this into an LLM-based system, you get a response like this using GPT 3.5. Now, I'm not going to read the entire response, but I will tell you that what 3.5 did was primarily give like a line-by-line interpretation of what was happening. It didn't give like a high-level conceptual response to what was happening. ChatGPT 4 did a slightly better job, according to experts. And you probably won't be surprised that if you put in a prompt, in this case, the prompt was, imagine that you are an instructor for an introductory CS course. It did an even better job at getting an answer that the experts thought was better. And this actually raises many more questions. I will touch them in a little bit, but I want to also just note that this was a pretty easy question. And both all three systems, the bag of words system, the 3.5 system, and 4.0, pretty much graded it correctly, even though they didn't get the conceptual resolution the same. But let's take another problem that wasn't as easy for students. In this case, looking at this code, a student responded, it returns a list of strings from another list. And one of the things I also want to note is there is a grading rubric. The rubric looks at whether or not the answer accurately describes the code, if it's high level, and 3, if it's sufficiently unambiguous that an engineer can reproduce the code with the descriptions. And these criteria are fed into the system. And so what happened with this question? Well, the TA graded it as incorrect, 3.5 graded it as correct, and 4.0 graded it as incorrect. And again, it was because this third criteria right here in our rubric, the TA and 4.0 decided that it was not sufficiently unambiguous that an engineer can reproduce the code. And it explained it, saying that given the third criteria, the description might be a bit lacking in specificity. An engineer can produce a function that fits a description, but might not replicate the exact code, and so on. And so what do we see from this? I mean, one, we start seeing some equity issues around GPT 3.5, and that should be 4.0. Apologies, there's a typo there. 3.5 at the moment is accessible to most people. Well, that's actually debatable too. It's more accessible than 4.0. You have to pay for 4.0, and it's a monthly fee. It also begs the question of, prompt design and system proficiency with systems. We've studied many, many systems in education. And one of the things that I can tell you that we've seen in almost every single system is that instructors, when presented with a system, do not go in to change the defaults. And so when this happens, when they do not change the defaults, they do not actually fine-tune the system to meet their learning objectives. We've seen this with CatMay. We've seen it with systems like this. And basically, I mentioned scale and speed earlier. If you don't have the knowledge or the underlying knowledge to know how these systems work and how to use them to reach your goal, using tools like this really help you do exactly what you don't want to do much faster and at scale, which kind of is the opposite of why we build these systems in the first place. So we are part of the problem. If we use these systems, we actually have to align ourselves with them and figure out, first of all, sit down and think about what our learning goals are and think about how to steer these systems to meet our learning goals. I also want to mention, just to exacerbate why we are the problem, I mentioned that we're working with many students who learn differently and students with disabilities, and we're exploring how they are using ChatGPT and similar systems. And I cannot tell you how often students tell us that professors or instructors' assignments are not intelligible. And we met this awesome student who's actually using ChatGPT to take their instructors' unintelligible assignments and create rubrics from them. And so there's this interesting tension between rubrics and the need for specificity and creativity. But I just, we need to do our part and maybe not just jump to automation, but figure out what our goals are with automation. And so I mentioned earlier that we do not want to just, increase false negatives. We want to think about, the learning outcomes as well. And we also don't want to just think about accuracy rates, which is something that we often, report and say, oh, we're good. We got 91%. Let's move on. And so what did we do? We did an experiment that explored people's experiences with false positives and false negatives with Bayesian modeling, specifically how these errors led to increases or decreases in learning. And I am not going to go into the details of this, but just stress that we looked at causal relationships around false positives and false negatives. And to give you some of the highlights, it turns out that if you separate the class into high performers and not so high performers, the high performers are just not good at detecting errors using such systems. Part of the reason we believe is because they're very confident. They're great students. They're confident in their responses. And so if a system marks something as correct and it's not correct, they just don't even consider looking at it. If they found something that was a mistake, they did a better job at reflecting on the feedback when they did detect the error, and they actually knew how to operationalize that feedback and to benefit from it. Students that were lower performers were surprisingly better at detecting errors. They detected more errors than the higher performing students. There may have been more errors, but they didn't have the ability to reflect on the provided feedback to improve their performance. And so what we found from looking at all of this was that from a learning perspective, false negatives were actually more helpful for learning than false positives. And so, what do we have left to do? And I want to stress that this is ongoing work. We really need to consider new workflows, this Lego model where we take one piece and just replace the human with a computer doesn't always work in some situations. So some other models to consider are, well, you have somebody working back and forth, having an AI-human dialogue, having people work together in a forum, or having multiple people be online working together as they move through this learning workflow. Another avenue that we've explored that also surprised us in its efficacy was introducing just a delay in the system. We're always about speed, let's do this much more quickly. But when we ran a study where all we did was give people the same response, but had them wait 30 to 45 seconds in between submitting their response and getting the correct outcome, it turns out people were much more critical of the outcome, and they were the learning increased just by having those 30 seconds to 45 seconds of waiting and reflecting on what you might get. So I can't stress the importance of just that, maybe we don't want to value speed so much. 45 seconds isn't too long to wait if it gives you the benefit of reflection. Also, we need to look at language, vernacular differences, and spelling. Different people from different cultures speak differently, and we know that these language models are biased in how they interpret language, or rather how they process language, I should say. And also spelling. Somebody might, have the right answer, but spell incorrectly. That's something we're looking at right now. But I also want to stress inclusivity and different learning styles and disabilities. Disabilities can be invisible. People could have ADHD, they could have autism, dyslexia. These disabilities can be progressive, latent, meaning they cannot be represented with a static binary marker. And sometimes people don't even know that they might have a disability. We need to address this as we conduct these impact assessment or audits via qualitative reviews with people with disabilities. I cannot stress just how important this is, especially because a lot of these algorithms pretty much create a almost homogeneous direction as to what is the correct answer. And I'll get to that a little bit more in a bit. We also need to formalize assessment. Like we've been conducting these audits, I said, for over a decade. But who should conduct these audits? When should we conduct them? And how should we conduct them? They also cost money. They're not free. We can't expect the people that make these tools to conduct these audits. And sometimes you have to conduct them from the outside and you don't have access to the inside data. And also, people have to be prepared to sort of let go of an algorithmic system like the eating disorder organization did when they realized that harm was being caused. Also, I can't stress that we need to sit down and really consider what we want to optimize when we look at these different types of learning algorithms. Oftentimes we optimize for accuracy at the expense of other features, like learning, like creativity. Some text synthesis models, like I mentioned earlier, present a homogenic view of the world. And this could lead to specific types of explanations and not really allow for like out-of-the-box type thinking. Maybe we want to, grade for improvement as opposed to just what somebody's already done. And how do we actually encourage critical thinking as opposed to just, fitting the mold of either this bag of words or this one outcome from ChatGPT for an elegant solution to a problem? So what do we do moving forward? Number one, awareness is key. And that's something that we found almost in every single project in the 13 years that we've been doing this. People should know that an algorithmic system is at play. And I can tell you that in many of the systems that we've explored, people are not aware of that. And if they are not aware of that, they cannot create mental models to be able to compare and contrast and go back and forth. Also, as these systems become more authoritative and more fluent, the responses can be really misleading and people can take them at face value and not even consider the fact that there might be an algorithm at play. Accountability. We need to sandbox these systems before we deploy them in the real world. It's amazing how often some of these end up in the real world, and they're super fun to play with. Like I love playing with repurpose.io at the moment with images. It is awesome. At the same time, if you use them in socio-technical systems where people's grades are at stake, people's learning is at stake, and outcomes about whether or not they go to university or outcomes about whether they get a job are at stake, we really need to be more critical of the systems. As people use these, let's say this is a grading system, where did they get the source data from? Did they get it from the Onion? Did they get it from Wikipedia? Did they get it from Reddit? And a lot of these early systems did get their data from Reddit. What should not be sources? Should something be blackballed? And again, audits and impact assessments, I believe, are critical. We also need to think about how we create these interfaces and provide seams in them. When I first started in HCI in 1980, we said that if you ever saw a system that wasn't slick and shiny and didn't give you exactly what you wanted instantly, that it was a bad system. 30 years later in my career, we've taken an about face. And it turns out that you want to show people multiple answers. You want to show people like alternative ways to do something, because highlighting these seams actually helps people make sense of what the system is doing. So one day, Facebook actually had a glitch. And there were some printf statements on almost every post or on many posts that appeared on people's news feeds. Now, I thought this was awesome. Every person I spoke to thought it was awesome because it gave them a clue as to what Facebook valued and what they were using as criteria to prioritize what showed up on people's feeds. Like, I think they should do this, like have a glitch day once a month. They were not so crazy about this idea. But you can imagine having something like this in a grading system. You have to leverage this off with people trying to game a system, of course, but trying to figure out what to reveal, like what the right reveal is to get people to learn how to use the system has shown tremendous impact in our work. Contestability. We've been running workshops now for several years around, citywide contestability around using AI in city infrastructure, university infrastructure, class infrastructure, social infrastructure. People need a way to contest. And there's also, I should stress, there's a bias in this as well. One of the biases that we see in contestation systems today is what's called the analog privilege, which is people that are like really high up and affluent know who to talk to actually bypass the computing contestation system and go directly to a source. And so if anyone's ever been on a phone call where you're trying to talk to an algorithmic system trying to get what you want, you realize the power of being able to go outside through an analog channel. And it turns out that there are classes of people who can do that and classes of people who cannot. It's also important to provide people with alternatives, not just this computing infrastructure. Contestability also, that this back and forth offers new opportunities for learning, we found, and it gets people to think about ways they hadn't thought before. So the first wave of feedback that you get, you kind of expect. The second wave of feedback that you get through contestability, that really gets you thinking about things you hadn't thought before, like that second, like derivative order. And again, I already mentioned analog privilege, and it is a thing, and we're seeing more people writing about it again today. And again, critique. Critique is so important. There are allocation and representational harms. Allocation harms being those harms that where you might get more resources than you. Representational harms are much more harder to quantify. For example, somebody who's Black being labeled a gorilla on Google. This perpetuates a stereotype and causes long-term harm, and it goes on and accumulates. There's also, using these systems, environmental concerns. And I'm sure you've thought about them already. I just feel like I would be making a mistake not mentioning them again. Around the energy required to train these systems. ChatGPT, for example, takes over $400,000 to train. And there's also a cost associated with using it when you make a query. There's also the water required to cool all of these systems. Should we be making these systems frivolously, to play jokes on people? I also want to stress that we talk about using these systems to save money and to save labor. But there's a lot of ghost work involved here, and we don't even think about it. We don't think about the millions of people involved in just getting ChatGPT to work. And we also don't think about, when they break, the number of people that have to jump in unexpectedly to fix these systems when they don't behave as expected. And we need to start thinking about what and who we are replacing when we adapt these systems, because we want to, do things at scale and at speed. And so we are seeing a bit more. I wanted to point to this document from the Center for Data and Society. They are providing also guidelines for people who want to conduct impact assessments. And again, these impact assessments can happen at many levels. Like I was just talking to the heads of impact assessment in the city of San Jose. For every algorithm that will be used in the city for city infrastructure, it has to go through them and go through this impact assessment policy. Thank you. And I would argue that we should not be scared that impact assessments take a long time. Like our impact assessment of this tool took months. They take time and they take lots of labor to conduct. I also want to stress that even though these algorithms were at play, the work was also graded by TAs. But we do need more research on how we want to create these audits. We need more research on these impact assessments and how to continuously monitor them. Because these can change along the way. We all know that these systems are dynamic. They don't work the same way tomorrow as they might work today. And we need to figure out when things go wrong. And we are, we've got enough experience now to really know how to conduct some of these assessments and audits. So this is an ever-changing field. So I'm not going to say the end, because the work is to be continued. And I just wanted to thank some of the folks that have helped us. And if there's time for questions, I'm happy to take some.
We have time for a few questions.
Yes.
So one of the things I did not see in the presentation, I was a little late, so maybe you talked about it, is whenever you use a black box system, besides just being able to be wrong or right, there are specific exploits that can be used, in particular like prompt injection.
Yeah.
Have you considered like the implications of that? Because whenever there's an exploit in automatic testing systems, I remember in my undergrad, one of them, there was a Moodle failure. You could just like click a button and people would see the correct answer for multi-choice questions, and that's going to get exploited. How can we ensure that these exploits are not being used without continuous supervision of the system, right? Because whenever something is discovered, it spreads like wildfire.
So the idea of gaming a system has been pervasive throughout. And the idea of gaming is also what makes you think about what you want to make transparent and what you don't want to make transparent, right? So I'm not surprised that Google didn't want the glitch day. I mean, that Facebook rather didn't want the glitch day. And so in creating some of these automated systems, one, there are specific prompts that people can use and some of the ones used today. So you don't give people full freedom. You give people specific options. So that the guardrails are essentially what people are using at the moment. That's version 0.1, right? That's something that you start with. Somebody that's really good will find a way to jump over those guardrails, jump into the system and infuse whatever they want. The majority of the people will not do that. So at the moment, we've got these initial guardrails in place where you have a interface that doesn't give you access to the back end, where you have like a multiple choice system and you can choose what you want. But we're finding that people don't even do that. And so it's these exploits are a problem. The exploits happened with a small percentage of people. The systems that are at play right now are still experimental, and we haven't gotten to that phase yet, but it's always top of mind. No, but that's an excellent question. And in the companies that we've talked to around what they release and what they don't release, for them, this is top of mind. Like, they don't want to release anything that not only will game the system, but might give people insights into their intellectual property.
Hi, Karrie. This super interesting question. Interesting answer. Great talk. I have a hypothetical idea. You talked a lot about how to improve education and generative models, et cetera, et cetera. What about improving education by helping the teachers become clearer? The example you gave about how the teachers' questions are not clear, the assignments are not clear, you could turn it on its head and actually evaluate the questions.
Yeah, we're thinking along the same lines. It's I think that's a space where I'm at the moment, I'm seeing actually much more opportunity there. I think that I personally could use some help modify. Like, oftentimes as a teacher, you teach a class multiple times. It's so much easier just to keep adding stuff to it as opposed to like reimagining it every year and making it concise and making it succinct. We're finding that what the students need, and we're very lucky to be working with DRES on campus, our Disability Resources Center. And the suggestions and the creativity around ChatGPT use from our DRES students far surpasses those of the students that I meet every single day. And so I think what you're saying, Tandy, is absolutely correct. I think we need to be doing that. And I think that you should talk to my student, Alex, because that's what he's working on.